So in the previous class, we started discussing about the Laplace transforms for solving the electrical circuits or solving the transient response of electrical circuits. We started doing some problems on this. So now we'll do some more problems. So this is the circuit. So this is 2 ohm, right? So this is half farad. This is 0.1 Henry. And this is 1 ohm. And this particular switch is closed at t equal to 0. And the source is a function of time. So let us assume that this value is 0.1 e to the power of minus 5t. Minus 1, so 0.1 e to the power of minus 5t volts. Right. So this is the one, this is I of t. So find I of t for t greater than or equal to 0. So let us assume that this is voltage across capacitor V and this is inductor current IL. So what are the initial voltage across the capacitor? What is the voltage across? Yes?
0.
So both are 0, right? So inductor current IL of 0, so that is also 0, and voltage across capacitor, so this is also 0. Right? So once this is done, so what is the next step? What is the next step?
Converting circuit into S domain.
So convert this circuit into a Laplace circuit, right? So how to do that? How to do that? So we have circuit like this. So inductor, resistor. So there is no initial conditions, right? So what is the value of this? So what is the value of this resistor? Sorry, this source. So what is the value of the source or this value of this Laplace? So what is the Laplace for this?
0.1 by S plus 5.
Yeah, 0.1 by S plus 5. Agree? So next, so what is the Laplace for inductor if you have no initial conditions?
S into 0.1, sir.
0.1 S. So resistor so remains same and this capacitor 1 by 2 farad. So how it will change?
2 by S, sir.
2 by S. Good. So next resistor.
2
This is as it is, right? 2. Okay. So generally, so we will not mention the signs. So this is just 2 only. Okay. So there is nothing when you transform this one, it's no longer a resistance, right? So this is just 2. This value is 1 and this value is 2 only. Okay. For more correct representation. All right. So now we require the current through this current we require, right? Current through the 2 ohm, so that we require. So how to find that current? So how to find that current?
Sir, voltage across capacitor is
So
voltage
voltage
across
across
resistance.
capacitor, right?
Yes,
Divide
sir.
by,
Divide by resistance.
so divide by resistance. So how to find the voltage across capacitor? So that will be this voltage minus this voltage, right? Or so just find out this total current and apply current division principle. That is also easiest way, right? So what is the total current in this circuit? So these two will come in parallel. Agree?
Yes,
So
sir.
these two will come parallel, right? So what is the total current? So let us assume that this is I T. So what is the total current? So 0.1 by S plus 5 divided by 0.1 S plus 1, okay, plus, so what is the parallel combination of these two? What is the parallel combination of these two? So what is the parallel combination of these two?
4 by S by 2 by S plus 2.
2 by S plus
4 by 2s plus 2.
4 by 2S plus 2 means 2 by S plus 1.
Yes, sir.
2 by S plus 1. You said 4 by 2 plus 2S. So that means 2 by S plus 1. Just check it out.
check it out, let's check it out. Check it out, let's check it out.
Check this one. Is this correct? So this is the current. So if you solve this one, what you will get?
Two by S plus 1.
2 by S plus 1 only. Okay. So it will be something like this 0.5 by S plus 5 divided by, so 0.1 S plus 1 into S plus 1. Okay. So what else you have? Plus 2, right? By S plus 1. Is this correct? So that means it will be 0.1 into S plus 1 divided by 0.1 S plus 1, S plus 1 plus 2. This entire thing, so we need to multiply with S plus 5. So don't solve this one, right? Is this correct?
Yes,
Yes,
sir.
sir.
Okay, so don't solve this one unnecessarily, right? Sometimes maybe cancel, right? This is IT, right? So what is the current I? So what is the current I now? What is the current I?
2 by s by 2 by s plus
2
2.
by S by 2
2
by
by
S
s.
plus 2 into this IT, right?
Yes, sir.
So it will be 2 by S. Okay, so what you will get here?
1 by S plus 1 into
1
IT.
by S plus 1 into IT, correct?
Yes, sir.
Yeah, do it. Solve this one. So what you will get?
0.1 by s plus 5 into 0.1 into s plus 1 into
0.1 by
s plus 5
s plus 5
into 0.1 into
0.1 into
s plus 1 into s plus 1
plus 1 into
s plus 1 plus 2
s plus 1
plus
plus 2. Just solve it. Just expand this one or just try to solve this. Yeah.
So I've got the answer. Can you please check it?
Yeah, tell me.
So minus e raised to the power minus 5t plus t into e raised to the power minus 5t.
No, you tell me this point. So this is what you'll get. Tell me.
So s plus 5 whole square, 1 divided by s plus 5 whole square
1
into s
divided
plus
by
6
s plus 5 whole square
into s plus
into
6.
s plus 6. Okay. So that means minus 0.1 will be cancelled out somewhere.
Yes, sir.
Okay then. So it will be 1 by s plus 5 square into s plus 6. Okay. So how to write this one?
Partial fractions.
Partial fractions, right? So doing the partial fractions and tell me what you will get. Partial fractions means it will be so tell me what you will get if you are doing it partial fractions.
1 by s plus 6.
1 by
S plus
s
6.
plus, s plus 6. No, it will be 1 by, it will be something like this, right? 1 by s plus 5 square. Okay, some a by s plus 5 square. Okay, minus of 1 by s plus 5. So you will get 1 by s plus 6. Okay, something like that you will get.
Sir,
This correct?
sir.
If it is something like this, I just remember that if it is s plus 5 and s plus 6, something like that, right? So we can write straight away is s plus 6 minus of s plus 5. So this entire thing will give you 1, right? So this will be s plus 5 square into s plus 6. Okay. So this can be separating these two terms. So you will get s plus 5 square minus of s plus 5 will be get cancelled, right? So you left with 1 by s plus 5 into s plus 6. Agree?
Yes, sir.
Okay. If you further, right, if you again, if the difference is 1, right, if you further this separating this term, so you will get this. You can straight away write, so without calculating a, b, c values. If the difference is, if it is s plus 5 and s plus 6, so in that case, you can straight away write this. I think you might aware of this, right? If this is the case, okay, so what is its inverse Laplace? So what is its inverse Laplace? What is its inverse Laplace, this one?
e power minus 60.
So what is the first one? 1 by s plus 5 square. So what is 1 by s plus 5 square?
e raised to minus 5t into t.
e to the power of
T into e to the power of minus 5t.
minus 5t.
Minus 5t only, right? Yeah. So this one, so it is straightforward, e to the power of minus 5t. And this is plus e to the power of minus 6t. Okay. So this is its solution.
Sir,
Yes.
sir, in third last step means s is in s plus 5 into, sir, this is multiply with overall equation, no? Means
Which
0.1
one?
into, so third step from
This
above.
one.
Yes, sir.
This one I'm not sure whether it is right or wrong. You guys only said this.
Sir, s plus 5 multiply to whole equation means 0.1 into s plus 1 whole
This
square
is the
plus
one you're
2.
saying.
Yes, sir.
Okay. It's just simple mathematics. That's all. Okay. All right. So this is how to solve if the initial conditions are 0. So now we'll try solving some problems. So what we do, so when you have some initial conditions are there, right?
Sir, your voice is low, sir.
Actually, some work is going on. Okay. So let's try to solve. So one more problem on this. So this is off Farad. This is 1 Henry. So this is 3 ohm. And so this is 5 into E of t. Five into E of t. Right. And this is 5 volts. No, sorry. This is E of t only. And this is 5 volts. This is position 1. So initially it is position 1. And it is moved to position 2 at t equal to 0 seconds. So it is moved to position 2. So initially is at position 1 and it's moved to position 2 at t equal to 2. So initial conditions are given. So inductor current at 0 minus, so that is 2 amperes. Okay. And the capacitor voltage at 0 amperes, so that is 2 volts. All right. So if these are given, so no need to calculate that, right? So that means we are overriding our calculation. For example, in this particular case, if u of t is given, right? So in this case, if you calculate that, so you will get some different values, right? Agree? So what you will get here, the inductor current will be 0, right? And the capacitor voltage will be 1 volts, right? Agree with that?
Yes, sir.
Yes, sir.
Okay. So just we are overriding, right? Sometimes in some competitive exams, what they do to confuse you, so they're given the values, right? So no need to calculate that one, right? So now once this is done, so what is the next step? At t equal to 0, the switch is moved to position B. So the switch is moved to position B. Okay. So what you will get here? So now we have source here, right? So this one, an inductor. So inductor, so how to represent the equivalent circuit in inductor? In one of the class we discussed two ways to represent, right? So two ways to represent that. In this particular problem, you require to calculate the I of t. So I of t for t greater than or equal to 0. Okay. Similarly, you have capacitor. So these two are associated with some initial conditions, right? So, but you require current. So how to represent that initial conditions? So you will represent with voltage source or you will represent with current source. So which is the best thing you feel? Current source. So that means you will represent something like this, right? So what is the disadvantage when you represent something like this? So here in the question, you are asked to calculate the current, right? If you represent with voltage sources, right? For example, if you represent with voltage sources here and another voltage source here, the advantage here straight away you can apply KCL. Agree for that? Straight away you can apply, straight away you can apply KVL, right? So if you can apply KVL, so you can get the voltages. Understand? So now, thing is that, so what we observed that instead of using a current source, if you use a voltage source, so that means the problem will be simplified. So now tell me, so what is the source voltage? So what is the source? So what is the Laplace for this 5 volts? What is the Laplace for this 5 volts? What is the Laplace for 5?
Five
Yeah, sir.
only, sir.
0. What is the Laplace for a number?
Yes, sir.
So can't we write 5 into e to the power of 0 t? So what is the Laplace for this?
5 by S.
What is the Laplace for this? 5 by s, right? Understood? Right, it's not 0, so we can write something like that 5 into e to the power of 0 t, so it will be 5 by. You are agree with this?
Yes, sir.
So you agree with this? It's 5 by s.
Yes, sir.
Okay. So don't, it's not a 0. So next step. So what is this resistor? So it is as it is, right? This is 3 ohm.
3 ohm.
So inductor S
Yes,
into
sir.
L. So only S. Next come to this this DC source. So how to fit this DC source?
L into initial condition.
Right. So what is the initial voltage? L into its initial current, right? So what is this value?
2 by S.
2.
2 into 1, right?
Yes, sir.
It is 2. So what is the polarity? What is the polarity?
Plus
Will it be
minus.
plus minus or minus
Minus.
plus?
Plus
Minus
minus.
plus.
Just check it out. Check your notes. Check your notes once. So what is the polarity here?
Minus plus.
No, this is for capacitor. Yeah. So what is the polarity here? Minus plus, right?
Plus. Yes, sir.
Okay. Similarly for capacitor, what is the polarity? Plus minus. Understood?
Yes, sir.
Yeah. So this is minus plus. So its value is 2. So capacitor, it will be 1 by SC, right? What is 1 by SC? It is 2 by S.
Yes,
Agree?
sir.
2 by S, right? So what is its initial voltage? It is 2 volts, right? So what is the value here? We already discussed that this is plus minus, right? What is its value?
2 by S.
2 by S. So now apply, this is I of S, or simply I. So what is I here? I of S is I. Or else we need to apply KVL first, right? So what you will get if you apply KVL in this equation? What are the sources here? 5 by S, okay, minus 2 by S, correct?
Plus
Or
2.
plus 2? No, this is plus 2. This will come first, right? Which is equal to, so what you will get here, I of S into, or I into
3 plus S.
3
sir.
plus S plus 2 by S. So calculate the value of I and tell me. So what is I here?
Sir, 2s plus 3 upon s square plus 3s plus 2.
Wait, what is the answer? 2S plus 3
3
upon, yeah,
s square plus 3s plus 2.
S square plus 3S plus
s plus 2.
S square plus 3S plus 2 means S plus 1 into S plus 2.
Yes,
Agree?
sir. Yes, sir.
Yeah, tell me this is the one, right? So now I of t, so it will be inverse Laplace of I of S, right? So what is the answer? 2S by 3. So how to write 2S by 3?
Answer e to the power of minus 2t
I
plus
think
e
it
to the
will be
power of
S
minus
plus
3.
1 into S plus 1. Wait a second. I think is it directly we can write now, it is S plus 1 into 1 by S plus 2. Is this correct?
Yes, sir.
S square plus 2S plus, yeah. No. Yeah, it is correct only, right?
Yes, sir.
1 by S plus 1, 1 by S plus, you can straight away write this. So what you will get here?
E
So
to the
it is
power of minus
e to the
2t
power of
plus e to
minus
the power
t,
of minus 3.
just e to the power of minus 2t. That's all. So this is for t greater than or equal to 0. Sometimes what we write, right? So when you're writing the response, right? So if you know the answer is e to the power of minus t plus e to the power of minus 2t for t greater than or equal to 0, right? So instead of writing these terms, sometimes we'll write e to the power of e minus 2t into u of t. So both are same. So no need to write. That means t greater than or equal to 0. The terms we just sometimes we remove the term. So instead of that, so we will write that u of t. In some of the cases, so we will write like that. Okay.
Sir, can you switch to please? Yes.
We'll try to solve one more problem. Yeah. So 10, sorry. This procedure is simple, right? So just obtain the equivalent S domain circuit and just apply KVL, KCL or source transformation, right? So all those methods to obtain. So this is 2 into delta of T amperes. I will tell you what is delta of T. So this is 10 e to the power of minus T U of T. So this is 10 ohm and this is 0.1 farad and this is voltage across T, so that we need to find. So V of T is T greater than 0. So here you're aware of this, right? So what is this one? What is this function U of T?
Unit step function.
Step function.
Step input, right? Similarly, this is known as delta of T. So this is
Correct.
known as unit, right? Unit impulse function. So unit impulse function, right? So how exactly it is defined as, right? So you have some timeline here. So this is corresponding to T equal to 0. So we have infinite here. So we have minus infinite here. Right? So this is y-axis somewhere here. Okay. So here, so from minus infinite to 0, its value is 0. Okay. And from T equal to 0 to infinite, so this value is 0. And it will only adjust from T equal to 0 minus to T equal to 0 plus. It will only, its value is only adjust from T equal to 0 minus to 0 plus. So that means this value will be something like this. So it will exist at only 0. Right? It will exist at only 0. Just it will give some shock. Okay, for some circuit, so it will give some shock. Something like that, right? So it will give, and immediately it will be removed. So that means its value is, right? So that where you have value, so that will exist only at T equal to 0. For other times, so rest of the other times from infinite to 0 or 0 to infinite, its value is 0. So it will only adjust between these two, right? So theoretically its value is equal to infinite. Okay, so theoretically its value, so that means infinite. But practically, for example, it is 2 into delta T, for example, this is 2 into delta T, its value is equal to 2. So T equal to 0, so that means that value is equal to 2. So rest of the cases for T equal to less than 0, its value is 0, to greater than 0, its value is 0. So that means it will give some shock, right? For example, you connect source and just immediately remove that. Understood? So you will connect some source, for example, 10 volt source is there, right? We just connected that source and just we immediately removed that source. So all things are happening in 0 seconds or a very small duration of seconds of negligible duration, right? So that is known as unit impulse function. Unit impulse function, right? So that means when it gives a sudden jerk to the circuit, so how it will respond, so that we're going to study, right? So more details about this, so we will study in control system, right? In control system, so when you give a sudden jerk to some controller, so how it will behave, so that we'll study in or more detail study in the control systems, right? So similarly, this can be, right? So this function can be defined something like the integration of 0 minus to 0 plus, so delta of t dt, so which is equal to 1. So we have several scenarios. For example, we have some timeline is there. So this is corresponding to 0. So this is minus infinite and this plus infinite. So how exactly these functions are defined? So for example, you have here somewhere here. So for example, this is minus 3 seconds. Okay. So this is 0 seconds and this is plus 4 seconds. Its value is 2. This is 3 and this is 4, for example. So this can be written as, so how to write this? 2 into its value is 2, and so how to write this one? So delta of t plus
3 plus 3.
so 2 plus 3 3 3 seconds, right? And this will be 3 into delta of t, agree? And this will
Yes,
be
sir.
4
So
in
4
no,
into
no, just
delta
it will avoid
t
confusion. I
minus
will just write 5 seconds. Okay. So it will be delta t minus 5, agree?
yes, sir.
So this is how we represent, so similar to the our unit step function, right? Understood? So what is the advantage here? So that means if you give a sudden change or a sudden change in the system, or if you give a sudden jerk to the controller, so how it will respond? For example, the fan is running, right? So if you suddenly switch on the fan and you remove the supply, so how the fan will respond? So that we are going to study. Understood? Okay. So more details are not required right now. So just remember this much only for time period of time, right? So this is the circuit. So how exactly the circuit will behave, right? So here the thing is that, so the Laplace for this one, so what is the Laplace for this one is delta of t. So if you apply Laplace, its value is equal to 1. Understood? Its value is equal to 1. Okay, right. So here, what is the first step? So we need to find the initial conditions. So we need to find the initial conditions.
Sir,
Yes.
sir, so Laplace transform of unit impulse function is equal to 1.
Yeah,
Okay,
this
sir.
one, this is 1, not this entire thing. The initial conditions I have given for this.
No, sir.
Yeah, you can find out the initial conditions, no, for this. Can you find the initial conditions? Yeah, no, initial conditions are given actually. So V naught of 0, so which is equal to 5 volts. Okay. So V naught of 0 is 5 volts. Right. Voltage across this capacitor, that means V of 0 equal to 5 volts. So the capacity, initial voltage across this capacitor is 5 volts. Right. So what is the next step? So convert this into a equivalent S domain circuit. Right. So what you will get if you convert this into an equivalent S domain circuit? So can anyone tell? So we have DC source here, right? So what is the Laplace of this DC source?
10 by s plus 1.
Yeah, good. 10 by S plus 1. So what is the next element? We have in resistor, right?
Yes, sir.
So we have resistor, so followed by another resistor. So what are these values? 10
10
ohm.
and 10.
10. This is also 10.
10 and 10.
Okay. So next we have, so what else you have?
Capacitor.
Capacitor. So what is the best way to represent?
Voltage.
So what exactly they asked here?
V of t.
So V of t.
So V of T, right? So voltage across the capacitor. So there are two possible to include the, so one is like this and another one is like this, right? So which is the best one you feel? So you require voltage across the capacitor. So how do we represent? It will represent as a voltage source again in series with the capacitor, or you'll represent as a current source.
Current source.
Current source, sir.
Why current source?
We can easily find voltage also there.
Yeah, good. So if you represent this one, so with a current source, right? So this will be the voltage source. So this voltage right away we can write V of T, right? Agree? Not V of T. So this will be V of S. Agree? And this can be represented as a current source. Okay. So what is the current source? It is upwards. If you remember that, that is upwards only, right? Just check it out.
Correct, sir.
Okay. And what is the values here? So why we represent it with a current source? If we represent with a voltage source, the drawback is again, so we need to find the drop. So we need to subtract that and we have to do some extra efforts, right? So what is the value here? Capacitor
10 by S.
10 by S.
Yes, sir.
So what is the source value? It is 5 volts that is already given, right? So 5 into, no. So
0.1.
the capacitor value,
Plus 2, sir.
5 volts it is already given, right? No. Why 5 plus will come?
It was 0.1, sir. We get 0.5.
Is it 0.5? It is all, what is
Yes,
the
sir.
value of this capacitor? So this is 0.1, right? So 0.1 into 5. I think it is 0.5.
Yes, sir.
0.5, I think. 0.5 only, right? 0.5 by, no.
Yes,
0.5 only. 0.5 S.
Yes, point.
Okay. So what else you will get?
Why
So
is
you have
it
one
there?
more source is there, right? So what is the value of this source?
2.
So what is the value of 2 into U delta of T? So this is upwards, right? So this is 2 amperes. Just
Just 0.5?
0.5, I think S is that S is there?
No, sir.
No, just fine. So this is 2 only, right? So no units actually, in fact. There's nothing wrong when you represent with units, but these are dimensionless, right? So what is the one you required? VFS, right? So which method you will apply? KVL, KCL, or so what is the preferred choice to obtain VFS?
Sir, so that
Yes.
2 ampere
KCL.
which we have written, sir, so that will be only for means 0 minus to 0 plus now.
Yeah. But the impact is present for the rest of the time period, right? Okay.
Yes.
That impact will be for the rest of the time. See here the difference. This is represented with time S plus 1, right? So this is represented with only 2. The meaning is if it is S, right? If it is S term is there, right? So what is its physical? What is the physical meaning of that? See here, this is constant. So that means it is not varying with time. So when you have this S means, so that value is varying with time. Understood?
Yes, sir.
Okay. So now tell me. So V of S, no, if you apply KVL, right, at this top node, so what you will get here? So V of S, I'll simply write V minus 10 by S plus 1 by 10, agree? Plus V by 10 plus V by 10 by S. Okay, so these are the outgoing currents. This is equal to 0.5 plus 2. Or, right, or you can convert this into a equivalent. If you're still right, you can convert this into equivalent current source. So this portion you can convert this into equivalent current source. So that also can be done. So what you will get V? So what you will get for V?
Sir, 5 into S square plus S plus 2.
5 into
S square plus S plus 2.
5 into S square. No, in the
Yes.
numerator itself we are getting S square.
Yes, sir.
Yes.
So 5 into 5s plus 7 divided
Sorry,
by
sir.
Five
s
into
plus 1 s plus 2. 5 into
5 into
5s plus 7
5s plus 7 divided by
s plus 1 into s plus 2
S plus 1 into
s
S
plus
plus
2.
2.
Yes, sir.
Okay. Yeah. So what we have to do? So this can be written as A by S plus 1, right? Plus B by S plus 1, I think. And S plus 2. So find out the value of A and B. So how to find A value? So substitute S equal to minus 1. So if you substitute S equal to minus 1, 5 into minus 5, 2, 10. Right. A is 10.
B is 15, sir.
15.
Yes, sir.
No, it will be 25S plus 35, right? By, so this value is S plus 2.
A is 10 only, sir.
So substitute S equal to minus 1. So that means 25 minus 1, 30. 30 by 1. 30 by minus 1. Which is 1, 10 only. I will calculate B. So B will be, so now it will be S plus 1. So it will be minus 2. So it will be minus 2 minus 1 minus 1 and it will be 2 substitute. So if it's 50, 50 minus 50 plus 35. So minus 15. So B is 15. Just check it out. Or am I doing wrong?
Correct, sir.
A is 10 and B is 15. So it
Yes,
will
sir.
be 10 by S plus 1 plus 15 by S plus 2. So this is V of S. So from this, so what is the final answer? So V of t 10 into e to the power of minus t plus 15 into e to the power of minus 2t volts. I think I remember when we are solving some generalized equations, right? I think, yeah, this is the one problem. So we are unable to find the result. This is the one, right? You remember this problem?
Yes, sir. Yes, sir.
Yeah, you just try to solve this. So by using Laplace, okay? This is the one, right? That day we struggled a lot to solve this. And we end with no result. Just try to solve this problem by using Laplace. So now it is easy only. I think we need to calculate I of t. Okay. So go back to your previous classes and just try to solve that problem. So we'll try to solve more. So these kind of things are slightly difficult, right? We remember. So this is 10 into E of t. Okay. So you left with 1 ohm here, and this is 4 ohm here, and this is 1 by 4 Henry, and this is 1 Henry. Okay. So find out I of t, or find out, so this is I of t, I1 of t, and this is I2 of t. So find out I1 of t and I2 of t. Right. So if you remember that, so when you're doing with normal generalized differential equations, right? So it will be difficult, right? So now you can see that, so how much easy it is. If this is the case, so this is the equivalent Laplace, right? So there is no initial conditions here.
Sir, initial conditions are zero now.
Oh, no, right? Yeah, no initial condition. So what is the value here? 10 by S. So this is 1 ohm. So it is 1 by 4. And this is 1 by 4, right? And this is 4. And this value is 1. So this current is I1 and this current is I2. Okay. All right. So find the value of I1 and I2. So by applying KVL, right? So applying KVL, so 10 by S, so which is equal to I1 plus 1 by 4 into I1 minus I2. So this is first equation. Second equation is 1 by 4 into I2 minus I1, okay, plus 4I2,
1 by 4
4I2.
S no, sir.
What you're saying?
Or
Actually,
inductors.
This is S. Oh, yeah. 1 by 4 S, right?
There also one S.
Here. Yeah, this is S. 4 into I2 plus S into I2. Correct? Is this correct? Right. So we have two equations. So this is one here, two here. So we need to find the I1, I2 and apply inverse Laplace. So how to find I1, I2? How to find I1, I2? So calculate the value of I1 and substitute in this I2 expression. So that is one way. Or else we can solve by using matrix form, right? Can we solve that by using matrix form? So we can put this in matrix form. So it is 10 by S, 0. So by inspection, you can tell the values, right? What is the value here? What is the value here? What is the value here in this matrix? You remember this?
Yes,
By
sir.
inspection, you can tell that. What is the first value?
1 plus S.
Plus S by 4.
1 plus
plus S by S
S
by
by 4. So what is the second value? Mutual terms. Minus 1 S by 4. Minus
yes,
S by
minus
4. And the last term?
4
4
plus
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 S
S by
plus
4.
4
Y.
plus S plus 1 by S by 4, right? That means S
Yes,
plus
sir.
1 by S4 means 5 by 5S by 4. So that means 4 plus 5S by 4. So this is, hopefully this is one of the easiest method rather than finding I1 and substituting there and solving here and there. Okay. So from this you can calculate I1, I2 by using Cramer's method. Okay. So for example, if the initial conditions are given, so just replace with a voltage source here and here. So just replace with a voltage source, so here and here. Okay. So just try solve. You can do this, right? I think we have not solved any problems with dependent sources. Yes.
Sir, do you know that previous answers that we can solve and confirm later?
No, in the actual, the thing is that in the question, so they mention like that, something strangely they mention. Okay. So solve the mesh currents in the below circuit and you may leave your results in the S domain. Okay. So that's why maybe that guy is not provided the results. I will provide the yes domain results if you want. Wait a second. So here I1 and I2. Just a second. Question number, yeah, got it. So it will be 50S plus 160 by S into S square plus 9S plus 160. No, not 160, 16. So whereas this I2 is 10 by S square plus 9S plus 16. Okay. So these are the answers for I1 and I2 in S domain. So rest, just calculate. Just calculate I of t in time domain. Okay, so next, so we have this. So 5 into e to the power of minus 2t volts. So this is 2 ohm. Right. So this is 1 farad. And this is 1 ohm. And this is 3 into e of minus t. And this is, we have another inductor here actually. So this is 1 Henry. And this is the current I that you need to find. So we have dependent source. So its values depends on this voltage. So V naught here, and its value is 0.5. So V naught. So V naught is the voltage across that 1 ohm resistor. So what you have to find is you need to find I of t for t greater than or equal to 0. Okay, right. So how to find the initial conditions? How to find the initial conditions? So for t equal to 0, so how the circuit will be there? For t less than 0, sorry. So what are the things at t less than for t equal to 0 minus, so how the circuit will look like? Okay, so tell me, so whether this source will exist for t equal to 0 minus,
Yes, sir.
what is its value then?
5.
Why 5?
So
What is
same
its
only
value?
5 into e power minus 2t.
T, if you substitute t equal to 0, what you will get?
5.
What? Hmm? So what is the value you will get?
5, sir.
5 volts.
Yes, sir.
Okay, so we have this 5 volts here. Okay, right. So whatever this circuit, so will it be present or not? It's 3 into e of minus t.
Yes, sir. It will be 3.
Yes, sir.
Yes, right? Understood? So this value is 3 volts. So what is the value here?
5.
5 volts. And this is 2 ohm. And this value is 0.5 V
0.5
naught.
V naught.
And this is 1 farad, right? And this is 1 ohm. So now tell me, so what is this
Sir,
capacitor? Yes?
sir, sir, in the question, sir, that 3u of minus t, sir, what does that minus t, sir, means?
Mhm. So we already discussed this, right? So that means u of minus t means, so the switch is on up to minus infinite to 0. From 0 onward, the switch is open, right? That means, so its value is not there. I think we discussed
sir.
this, okay? So when you're discussing, this is the one, right? So this is u of t. So what is u of minus t means? Right. So this is u of minus, this is up to that point, the switch is on, right? At t equal to 0, the switch is open. In other words, that value is 0. Okay. So u of t equal to 1 for t greater than or equal to 0. Its value is 0. So u of minus t is just reverse of that. So this is 1 for t less than or equal to 0. Its value is 0 for t greater than or equal to 0. Understood?
Yes, sir.
Okay. Right. So you can calculate the initial.
Inductor there.
Yes. This inductor we forgot. So you can calculate the inductor. Right, you can calculate the inductor. Of course, this will be short circuited, right? Anyway, so there is no use even it is there or not. So this is I, and this is V. So tell me its values. So what is V and what is I? Simple thing, you can convert this into its equivalent current source and you can find out, right? Or else you can straight away so find these values.
Sir, capacitor will be open.
Yeah, it will be open, obvious. So this will be open circuit, right? And this is short circuited. And this will be open circuited.
So
I
V is
not
7
2
by
by 3, sir.
Yes?
Sir, 2 by 3, sir. I 2 by 3. And
Yes,
sir, V
yes,
not
I
also
is.
2 by 3.
What is I?
2 by 3, sir.
2 by 3.
And so V not also 2 by 3.
So V naught are also means this is also 2 by 3. Okay, just check it out. Okay. Okay, so once you obtain these things, let's assume that these are correct, right? So once you obtain these things, so how you implement the Laplace? So how you will implement the Laplace for this circuit, right? So that is the next step. So this, what are the present? The source is present, right? Agree? And this resistance is present, and this capacitor is present. So capacitor is having some initial voltage, right? So this is, we represent that, and we have this dependent source. And we have this inductor, right? So this inductor is there, and some current is that is also flowing through the inductor, right? So here, so we represent, so with a voltage source here, and this is the one, and we have a resistor here, and that source is no longer present, right? So the 3 ohm source on the right side, so that will not present. Understood? So what is the value of this one? So what is the value of this source?
5 by S plus
5 upon S
5
plus
by
2.
S plus 2. So what is the value of this resistor? 2. So what is the value of this capacitor?
1 by S.
1 by S. So what is the polarity of this one?
Plus minus, sir.
Plus minus. And what is its value?
2 by 3?
2 by 3? Yes. Oh no,
Yes,
2
sir.
by 3 by S.
Okay. Yeah.
2 by 3S. Am I right?
Sir,
Sir.
Correct? Okay. So
so
now
the
come to
voltage
this.
across capacitor is not 2 by 3.
No, sir. Yes, sir.
It is
Right?
10 by 3, sir.
It's 10 by 3.
Yes, sir.
Just a second. The same current 2 by 3 is flowing here, right? So that means current is 2 by 3. So 5 minus, okay, 5 minus 2 into 2 by 3. So that means 5 minus 4 by 3. So 15 by
11 by 3.
11 by 3 is the answer. Is it correct?
Sir, 11 by 3 minus 0.5 V naught, sir.
Yeah, yeah. We have another one is there. Yeah, correct. No, no, that is open, right? Okay.
Yes, sir, but still, sir, we have
Yeah,
voltage.
but still that current is flowing here. Yeah, correct. But still it is V naught, right? What is the current it is actually flowing here? So 0.5 here into that
V
1
naught.
ohm. So what is that current here? So that is 2 by 3. Understood? So here, so what is the voltage here at this point we have obtained is 11 by 3. Understood? So from here to here, so this volt, what is the voltage here? 0.5, and the current that is flowing here is 0.5 into V naught. So V naught 1 ohm drop, right? So that means 1 ohm drop is 2 by 3. The current is 2 by 3, right?
Sir,
So that means it is 1 by 3. So that means the answer is 10 by 3. Yes?
so since it was open circuit, sir, then current won't flow in that part. No, sir. We will have to directly consider minus 0.5 V naught only, sir.
But this is source, right? Okay. So this is source only. So that means some potential is exist here. So here, this one is a source, right? You agree with that? So
Yes,
for
sir.
example, in the same manner, right, if you have doubt, right? So if I replace this one with like this, so what is your answer?
Yes, sir, but when we were considering, sir, the case was open circuit, no, sir. Then, sir, in open
No,
circuit
no,
branch,
that
sir,
is a
5 will
source, right?
current.
That is a source. Okay. But its values depends on the current on the other side, right? So this is the one. So what is its value here? For example, this value itself is, for example, 1 by 3 volts. So now what is the voltage across the particular capacitor?
10 by
Yes, sir.
Okay. So after all, it is a source, but its value is depending on some other else. If that value is 0, right? So that means there is no argument here. So here you cannot, now we cannot escape. We cannot say that this current is not flowing here, right? But means it's potential. If you assume this is ground, right? This potential is we have 1 by 3 volts. So that means this is 10 by 3. You all agree with that?
Yes, sir.
Okay. You all agree with that, right? Its value is 10 by 3.
Yes, sir.
So it will be, no, this will be 10 by 3, right? Okay. So next we have this 1 ohm. No, this come to this one. What is its value here? So this is the voltage V naught, right? That means its value is 1. So what is the Laplace of this one? What is the Laplace of this one? It's just 0.5 V naught only. So no change here. Okay. It is just 0.5 V naught only. So why? Because if there is change here, so automatically they will change here, right? So just replace with 0.5 V naught only, even in Laplace also. Understand? So next the current is flowing here. So what is the inductance value? So this is 1 Henry, right? So its value is S. So what is the polarity here?
Minus plus, sir.
The current is flowing in this direction, right? So now what is the polarity? It will be minus plus, right? Agree? You all agree with that?
Sir.
Yes, sir.
Okay.
2
So
by
what
3,
is its
sir.
value?
2 by 3.
2 by 3.
The only 2 by 3.
2 by 3
Only 2 by
only. Okay, right. Fine. So here the thing we need to remember is, so if you have dependent source, so there is no change in that, right? So it is already depending on that V naught, right? So whenever, so you are taking the Laplace of this one, so automatically you are consider here. Understood? So now it will become V naught of S. So this is also become V naught of S. That's the thing. Understood? So now you can solve it for So what the thing you need to calculate? So calculate I of t, right? That means inductor current. So this current you need to calculate, right? So just try to calculate that one. It's slightly difficult, so we need to solve all those things.
So we'll apply, sir, KVL.
So again, we need to apply KVL, KCL, and we need to find the I1, I2 values. Okay, it's not that easy. It requires some computation. Okay, right. Anyway, the procedure is not. So how you are solving, that's not that much important, right? So the thing is that, so when you have dependent source, so that will remain as it is. Okay. So again, another thing, so we must take care of the signs, right? So we are calculated, this is the inductor current, right? So that's why you have minus and plus sign. All right. So that signs you must take care. So this is the one, right? If it is an inductor, so this value is SL, right? What is the sign here? What is the sign here? If it is an inductor in S domain, what
So
is the sign?
minus plus, sir.
Huh?
Minus
Minus plus.
Minus plus, right? So this is the current flowing. Okay. Same manner we followed, right? S here minus plus 2 by S, 2 by 3. So this will be 2, it will be V I L of 0 minus. In the same manner we need to follow.
Sir, into L also.
Yeah, into L. Okay. So here the current is flow. If you assume this is the direction of current, right? So entire thing will be wrong. Okay. So this is about solving the so when you have different cases, or when you have dependent sources. So we'll stop here. Right. So we'll stop here, and perhaps this is the last class of your course.
Sir,
Yes.